Hello, and welcome to this GGB webinar. My name is Matthew, and I'll be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the Speaker Bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Additionally, today's webinar will include some polls. We want to hear from you. So we will be displaying some polls on your screen today, and in order to provide the answer, you simply need to click on the appropriate answer. Now, I'd like to introduce today's presenters. With us today, both coming from GGB, we have Matthew Steiner, the Senior Applications and Solutions Engineering Manager, and Jason Hardage, the Senior Business Development Engineer. To read more about our presenters, please look at the Speaker Bio window right next to the main presentation window. And guys, welcome to today's event. And with that, I will pass things along to you to get started. Please, go ahead.
Thank you, Matthew. Thank you for the introduction. Good morning, everyone. Good afternoon, I should say. Thank you all for being here, joining us for the presentation. We hope you enjoy and get a lot out of it. We're very excited here at GGB and looking forward to the presentation. So we're going to do things a little bit different today. You know, typically in our webinars or presentations, we may focus on a particular item like excessive wear with bearings or noise factors or corrosion or what have you. But today we want to focus on the actual power of partnerships. So what does this look like? What does this actually mean for you, the product designer, the specifier, or the manufacturer? For us, it's understanding the overall potential for providing the best overall solution for your design and application. So, doing things a little bit different, as I mentioned. We're going to start out with a poll. So it's very important for participation, just so everyone sees what's the biggest challenge you face managing friction and wear in your industry. So we ask that you do take a moment and look through these specific items and click on what is the biggest challenge you face managing friction and wear. So we'll give you say a minute or so, but take a moment, click on it, let us know what you face. What are you seeing? What's the biggest pain point for you in facing and managing friction and wear? Is it excessive wear? Is it the noise? Is your end user or customer, are they complaining of noise? We see that quite often. Is it the lubrication or grease? Or is it eliminating lubrication or grease, a wet or dry application? Is it size? Is it the weight of the application, the bearing that you're doing? Are you trying to reduce this? Is it the overall maintenance cycles that you're trying to eliminate or reduce time? Or is it the durability or the lifespan of the application? We see that quite often. How to increase that lifespan? Or is it simply a corrosion issue that you're facing with the components in the application? Or is it you're just trying to increase the efficiency? Or is there something other? I'll give you 30 seconds or so if you can click on that. And on the next slide, we'll, of course, it'll demonstrate what shows up. All right, we'll go ahead and move on over. Wow, look at this. It's a variety of answers. That's good. That's good. So we've got excessive wear, 7.5%. Lubrication grease, 7.5%. Same. Size and weight, 15.4%. Maintenance cycles. Yeah, maintenance cycles leading the poll at 30.8. Corrosion and efficiency. Great diversity of answers. That's good. It just goes to show you there's not one specific thing that we're always looking at, trying to solve and provide these solutions. It's good. So solving motion system challenges. Sometimes a standard solution or part can solve a problem, similar to a plug-and-play fix, if you will. On the other hand, there may be many missed opportunities to perfect a low-friction system. In reality, not one friction challenge is alike. As you may already know, each present unique circumstances, environments, and interactions from multiple surfaces in contact. For example, typically we'll see a variety of issues or complaints or questions, from automotive or from the automotive industry versus the aerospace industry or agriculture or construction. We're constantly looking into fatigue, vibration, speed, loading, weight and size of bearings. There's a lot of different variables that come into play that we step back and evaluate across the board. This is why identifying system factors through application engineering expertise and a thorough understanding of industry challenges and material science are crucial to determining the best solution. And the best way, I think, to provide an example and to relate to this, it's kind of like going to the doctor. You experience the pain or lack of mobility in your neck or your shoulder, and you explain all these pains and conditions where where it's heightened, where that pain is, and through the doctor's expertise, the experience, they're able to identify the root cause, the issue, prescribe any necessary treatment. It kind of reminds me of, I actually, from personal experience, I had an injury to the arch of my foot and kept trying to treat it with insoles and stuff like that, but ended up going to the doctor, to the physical therapist, and they actually treated my calf muscle with electronic stimulation, needling, and stuff like that. But it was going to the professionals, not necessarily looking at the pain, but what's causing it, seeing what the issues behind the problem is. So by combining detailed customer knowledge with our partner expertise, a solution can be derived quickly to solve almost any need, which includes suggesting the best materials. And Matt Steiner is going to walk through some of these various materials and solutions that we have at GGB. Customizing or modifying existing products. Say we take a stock part and if it's not working correctly for you, maybe we step back, look at it, reevaluate it. Maybe we end up putting a different chamfer or maybe putting grooves in the bearing. Something that'll fit your application, something that we can look back, redesign, or simply modify. Fulfilling special design requests or optimizing a design. Again, stepping back, looking at the entire assembly, see the problems, identifying those problems and treating the problems, or ultimately co-creating a brand new solution or material with you. So as we step into learning more about GGB and looking at our approach as a whole, understanding the complex science of interacting surfaces represents GGB's evolution from a part supplier to a global tribological consultant. We proudly provide both manufactured components and engineering expertise, helping our customers with the unique needs to create better surface engineering solutions. Again, stepping back, looking at the entire system, not just a component. That's extremely important. Again, sometimes it's not just that plug and play that's actually causing the problem. As you're looking at the slide, our comprehensive understanding of tribology allows us to apply our expertise to any surface, regardless of shape and material. And starting from the top, if you're looking, custom formulation materials, in-house capabilities for testing, materials development, tribology, defining the study of friction and wear, applications engineering, research and design teams, and testing in all locations. So looking at GGB as a whole, understanding the entire process, cradle to grave, beginning to end, looking at it from a solution standpoint, not necessarily just a plug and play and components. So thank you for allowing me to walk through a brief intro of GGB and the power of the partnerships. I'm going to turn it over to Matt Steiner now, and Matt's going to walk us through some of the real-life examples of where we've gone through that process. It's pretty amazing, honestly. So, Matt, with no further ado, I'll turn it over to you, buddy.
All right, thanks, Jason. All right, so as Jason mentioned, we're going to talk through a couple of case studies today. And show you kind of what this partnership looks like, how we like to interact with our customers, and the importance of going through this process and actually, collaborating together to find the right solution. So we talk about tailoring a customer experience, and that's really what it's about. Every application, every challenge, every, industry, they all have their own unique considerations, constraints, challenges, requirements, etc. And really what we bring to the table is a combination of three primary things. The first is tribological systems knowledge. So as Jason mentioned, tribology is the study of friction and wear, but it's really about understanding interactions within a system. So it's everything from galvanic couples and materials compatibilities of the right lubricants, the right materials, having the right surface conditions and clearances and so on and so forth. So getting all of those factors dialed in so that the system works the way that it needs to is kind of the key element that needs to happen for any moving system. But with that also needs the material science expertise, particularly if we need to customize a formulation, develop a new material, understand what's happening at the atomic level, within the system to make sure that it's doing what it needs to do in the application. And that brings us to the application, right? We need to understand what it does, what it needs to do, what the application is going to see, what environment it works in, what conditions it must tolerate, what the duty cycles might be, so on and so forth. And we have a lot of experience in various applications and industries, but we also know that all of them are unique, and we take the time to understand what is really driving the decisions, what is the real requirements of the system, and what do we need to make sure that our solution is bringing to the table to make it work as needed in the application. So as Jason had mentioned, the component level all the way up to the system level design and thinking, it's not to say that, it's only the complex, interesting, challenging things that are going to be of interest. It's also not on the other side of, well, we have our materials and we make them in certain shapes and that's just what we do. Depending on the need of the application, the need of the customer, we will tailor a solution and collaborate with our customers and outside organizations, our vendors, our supply partners, and so on, to develop truly unique solutions. So we have a lot of materials that, we're very familiar with. We have production capabilities to make, a certain range of sizes and configurations and so on. And if that's going to work for our customers, great, right? We don't need to re-engineer. We don't need to reinvent the wheel. But if that's not going to work, we also do mass customization. We source new components. We integrate sealing functions, all the way up to some of our customers come to us with a statement of requirements or even a loose idea of what something needs to be, and we work with them to develop new materials, new manufacturing processes, new processing technologies to get a solution that works in the application and delivers for what our customers need. So we're going to walk through two examples today, and hopefully they provide a good idea of what this can look like. They're two very different examples, and hopefully they help illustrate our approach and how we want to work with our customers. So we're going to start with another poll just to get a feel for what are the main causes of material degradation in your systems. So I'll open that poll. You can choose more than one, right, because every system has multiple considerations. Different types of wear, adhesive, abrasive, certainly not limited to those. Corrosion, thermal degradation, chemical attack, creep, embrittlement, other types of degradation, mechanical damage or loss of properties, and then other, because this is certainly not a comprehensive list. So go ahead and take a minute to click any of the ones that pop out to you as, yeah, that's something that matters to us. We've certainly encountered our troubles there. So we'll give another 10 seconds or so to click through that, and then we'll jump forward and see the results. All right, let's take a look at what you said. All right, well, I think that paints a pretty clear picture. So wear is certainly an element that, is something of importance. But we see those other things come in here too, right? Corrosion, thermal degradation, mechanical damage, all those things come up. No others, so I guess we made a pretty good list. So that's good. We captured the heavy hitters at least. All right, so one example that we'd like to share with you today is a manufacturer of hydraulic cylinders came to us a while back and said, do you have any materials that wear less than the bushings we use today? And we kind of stopped and said, that's a pretty generic question. Maybe. Let's try and understand the source of the wear. What's going on in your system? What do we need to be looking at here? So, let's start a discussion and make sure that, a bushing with a lower wear rate is what you really need. And they said, okay, yeah, come on in. We'll have a chat about it. And this is what they showed us, which is the bushing that they were using at the moment. And looking at this doesn't look like a bad bushing. This doesn't look heavily worn. There's some bronze exposed at the bottom of the image there, but not excessive, right? This is still a perfectly functioning bushing. So what's going on in the system? This is not something that a customer would come to us and say, we need help solving, because it's not really a problem. There's nothing truly wrong, at least with what we can see right here. So our question was, let's zoom out. What are you really trying to do here? They said, okay, well, we have, like most hydraulic cylinders, right, we have a seal pack. It's a combination of various, bushings and seals, and, the bushing that we're talking about is, the primary bushing. It's the first one in line, and, we think that the amount of wear that happens there is what's causing our seal issues. We said, okay. So the sealing is the issue. What's going on with the seals? Well, after a certain level of wear on the bushings, they start leaking. Okay, are they leaking in the area of wear, right, which would mean the seals themselves are probably wearing, or is it 180 degrees from there? They're unloading. Yeah, it's 180 degrees from there. It's unloading. Okay, so here's what we've got. Maybe what we're really addressing here is more of a diving board effect, where the actual piston rod in the cylinder is deflecting, right? More like a diving board. Maybe what we really need to be doing is looking at how do we support that better? How do we make it more of a bridge rather than a diving board? And they said, aha! we've already looked at that. We added this support ring on the other side of the seals in the last round when we tried to improve it, and it did improve it, but we're still not where we want to be. And we said, okay, well, let's look at some data, right? Let's bring some numbers into this. Let's start painting a picture of this system. What do we have here? So this is a representation of approximately what the cross-section looked like. And we have a bushing at the back, right? This is what the customer came to us asking about. And they said, and we see about 50 microns of wear there. Okay, all right. I mean, it's measurable. It's worth talking about. Let's see what's going on here. So we have seals that fail 180 degrees from the load zone. Okay, so we know it's an unloading issue, not a wear issue on the seals, or at least we can presume that. And then there's this support ring, which was recently added, and there we see about 200 microns of wear. And we said, well, if we're still seeing 200 microns of wear in that support ring, driving that bushing wear down to 0 probably isn't going to make a big dent, right? We still kind of have a diving board here, and we may need to, reinforce that support or re-envision it and see if, we can lower the wear out there. So that's where we started focusing our efforts. So GGB provides a number of different materials and products, and one of the things that this does is give us a lot of flexibility when it comes to tribological solutions. A lot of the polymers that we use are similar between the various products, right? We use a lot of PTFE, we use acetal, we use PEEK, right? We use a lot of different materials to achieve the tribological performance, right? And sometimes the decision is driven more by, well, what is the manufacturing process? What is the assembly process? How adaptable is that to a current system, so on and so forth. So we started looking at, okay, what can we consider here to, drive the wear of that support ring down as low as we can, right, and provide a better support for that shaft, keep those seals loaded, keep that piston rod nice and centered. So based on what we know of our materials, right, we know some of them work really well in oil, some of them work really well dry. In this application, we have one of each, but the dry one does have to tolerate some exposure to oil, right? So if oil is going to cause a material to swell or to react or to degrade, right, that's going to be a consideration, even though nominally this is a dry application, right? It's going to be exposed to oil, whether that's through leakage, through a little bit of oil film that comes through on the piston rod itself, right? Whatever we need to figure out there, right? So we looked at a couple of different things, and we knew that the metals and bimetals just weren't up to the challenge from a friction and wear standpoint, particularly on the dry side. Coatings prevented some logistical challenges. This was a 150 millimeter rod, so about 6 inches in diameter. We got this big rod guide that you don't want to be, shipping it around and doing a bunch of post-processing. So we said, all right, let's build a short list here of some materials we think will work from a tribological standpoint to get done what you guys need to get done. And we know our DP31 material works great in oil. It was kind of a shoe-in. And then we say, maybe we want to look at balancing the load. Maybe we'll try a different combination there. But we basically shortlisted a couple of concepts, a couple of ideas, and said, all right, let's see if we can put these through their paces. So we brought it back to our labs, and we said, okay, so let's try and mimic the customer's application, at least, as best we can. Test in the high loads and maximum speed conditions that they're going to see in the application. And sure enough, and we did test the current material that was in there, and sure enough, the wear rate was very, very high. One of our materials had a very similar wear rate. It was also very, very high, right? Not a good candidate for this based on those speeds and loads and the dry conditions. And that was a very telling thing for us, right? That material usually works really well dry. Not a good fit for this particular application, right? 2 other materials showed quite a bit of promise. We really liked what they brought to the table. Both had very low wear rates comparatively. And we thought, hey, we've got two good candidates here, right? Now, this is the dry testing. We know that it needs to tolerate oil, so we took it to the next step, add a little oil drop, right, to simulate a little bit of oil exposure. And, right, similar story. We found that some of the materials wore out very quickly, including the one that was currently being used, and some of the other ones had much, much, much better performance. They tolerated the oil just fine. We had a candidate that looked to be, really, really, really strong, and went back to the customer. We, shared this data with them. We said, here's why we think this solution will work. We're confident that, if you put it on a full-scale test, it will at least be a step in the right direction, and, we'll see where we end up. So that's what we did, right? So we worked with the customer, brainstormed some ideas, really understood what their issue was, brought it back in-house, said, let's vet some ideas, let's get some candidates going, and then went back to the customer with that data and said, here's what we think is going to work for you. And the result of that was an 85% reduction in the wear of that support ring, and no additional wear on the bushing. I think it actually reduced there as well. And as a bonus, we brought the coefficient of friction for that support ring down by about 50%. So not a primary goal of this activity, but certainly something nobody's going to complain about. So hopefully that gives some idea of the approach, the experimental way that we want to approach things, the collaboration, right? We want to really take the time to understand what the needs are, what the pain points are, what the potential solutions are, and then make sure that we're putting the best candidate forward to achieve the objectives of the activity. So jumping to a second example, and we're going to do another poll here to start. So in this one, we're going to be talking about downtime. So the question here is, in your industry, what is the average cost of a downtime incident? Right? And that can be in your facility, that can be at your customers' facilities. We know that each industry has different considerations. Some industries, something goes down and it's not that big of a deal. You use a different machine or send it in for repair. I used to work in diesel engine development, and if you have a fleet of buses and one of them goes down, you can sub one in and out. It's not the biggest deal. You've got a maintenance team there. It's not not a huge issue. On the flip side, if you have a long haul trucker with refrigerated cargo and he has an engine breakdown that's 100 degrees, he's sitting on the side of the road. His whole load is rotting, right? Whatever he had, it's melting, it's rotting, it's going bad. It's not what it needs to be. So that can be a huge, huge, huge loss. All right. So let's see what you said. All right. Looks like we've got that same distribution, right? Some are low impact, some are very high, and obviously some will be in between. But these can really, really, really add up fast. So what is the average cost of downtime? We did some preliminary research, and according to Aberdeen, in 2016, the average cost of downtime was $260,000 per hour. So that adds up real quick. In the automotive industry, you shut down a automobile assembly plant, you can pay up to $50,000 a minute, $3 million an hour, right? Those are big deals. I've seen in that industry people expediting parts by chartered helicopter to avoid shutting the line down. So that just goes to show you how critical it can be to keep these things running. So we had a customer that we worked with, and we were working with them on our typical application, day-to-day business, happened to be visiting them. And we got into this discussion of, what are some of the problems that you face? What's your biggest issue? What might we be able to help you with? And they said, well, I don't know if this is something that's up your alley, but we've got these support bearings and seals that, it's on this big piece of rotating equipment. And, you know, I mean, the bearings work fine, but sometimes we have an issue with the seals failing, which will then, you know, compromise the bearing, and it cascades from there. And, you know, I mean, that itself is not that big of a deal. You know, we can replace them. You know, there's constant maintenance things. You know, these equipment are, you know, they have a whole crew and maintenance and so on and so forth. But the downtime kills us. It takes us like 1 or 2 days to replace the current system that we have. And our engineers said, well, you know, let us take a shot at that. Let me think about that. Let me brainstorm some ideas. We'll come back to you and see if that's something we might be able to help with. So we took a clean sheet and said, okay, what does this need to do? What do we got to do here? You know, at face value, this does look like something that our materials can help with, right? It's the right speed and load combination. It's a good operating environment. You know, obviously there's a challenge to be solved here, but we think it's within our, you know, core competencies and our areas of expertise. So went back to the customer. We said, we want to talk about that a little more. Okay, so started aligning on, okay, what does this thing really need to do? It's not just a bearing, right? It's got a bunch of other things happening. It's a big piece of equipment. You know, it's not the most familiar application, so we really, you know, want to get in this discussion and understand what the true needs are. And they said, okay, yeah, you know, we need this to accommodate, you know, 30 millimeters of axial float. We're, you know, trying to reduce cost of ownership and kill that downtime. If we can eliminate that water pump and the filter associated with it, that would be a great added benefit. You know, we'd like to, you know, see what we can do to make it, you know, fit in the same space and, you know, be something that has a longer life and or reduced downtime if we do need to do some maintenance on it. So that's what we're looking at, and, you know, let us know what you think. So we took it back in and looked at it and said, okay, well, what are we looking at? What is the, you know, the real costs of these downtime? What could be a potential budget for, you know, a type of solution? And, you know, how do we step into that and go explore how we could develop something to solve this issue? So here's what we came up with. This assembly, as you see on the right, there were 2 generations of it, right? It is a multi-component assembly. It has, you know, a number of custom components. It has, you know, a bunch of components that we don't currently manufacture and, you know, are not going to enter that business. So we have to figure out, okay, how are we going to source this? What are we going to do in-house? What do we need new partners for? So on and so forth. And at the, I don't want to say at the heart of it, but one of the components in this assembly is a traditional GGB metal polymer PEEK-based bearing, right? So that is the primary tribological component within this system, but the ecosystem around it, right? Everything that exists to support that system, the seal that was designed specifically to keep the abrasive particles out to make sure that we don't have excessive wear of components due to the abrasive particles, right? That is the system level thinking that supports the tribological material that's really doing the work, right? And what we did was design this, like I said, from, you know, clean sheet of paper, put a known tribological material in it, and then build the system around it to, you know, to make it work for what the customer needed. And ultimately, we ended up reducing that downtime from 1 to 2 days to 1 to 2 hours, and stayed within the customer's budget. They said, "This, you know, we love it. We can't wait to put it on the machine. Give it a shot. We do need you to support us for, you know, the prototype builds. We need work instructions and assembly instructions and so on and so forth." And we provided them that whole package. So that is an example of where we step well outside of our, you know, traditional product offering to really provide something that brings the customer value beyond just dropping a bushing in. So with that, just to summarize, right, GGB is looking to develop partnerships with our customers where we can step into the sandbox, understand what the needs are, try some things out, vet some ideas. We go through these brainstorming sessions internally and then go back to our customers with 4 or 5 ideas and say, okay, yeah, this could work, that could work. This one, there's an issue that we see with that, right? But we're collaborating, we're working together, and we are, truly developing a partnership with these customers so that we can deliver something beyond just a drop-in replacement. Although both of these happen to be drop-in replacements at the end of the day, right? They have to fit that existing packaging space. None of them required a tear up of the whole system around it, right? So it's all scalable depending on the needs of the application, the needs of the customer. And when we work together to figure out the right solution, then at the end of the day, we all benefit. So with that, we're going to move to Q&A. And Matt, I'm going to turn it back over to you. I think you've been monitoring that, and you can let me know if there's any questions that came in.
Absolutely. Thank you both for that great presentation. And to the audience, thank you so much for participating in those polls. We're now asking for a little bit more participation. We're about to move into our Q&A session. We have our experts from GGB online and ready to provide your answer. You can now submit your question by entering it in the Q&A box and clicking submit. We're going to try to answer everything. However, if we don't get to your question during the live session, we will have an answer for you following the webinar. All right, we have a lot of great questions in the queue, so let's get to it. Here's our first question from the audience. What is the typical time frame of these types of projects? Guys?
Yeah, that's a good question, and there's not one answer. So the first example that I went through, I think the time frame was 6 or 8 months from the initial call to the validated product. So that one was relatively quick, I would say, for going through something where we did have to have testing and support it with vetting multiple materials and collaborating with the customer and providing prototypes for them to test on their rigs. So yeah, that was what I would say is somewhat normal, 6 to 8 months. On the flip side, some of the other ones, the second example I think was 3-4 years from that initial visit to when we actually launched with that customer. And that's not uncommon when we're doing something that is very complex like that. Obviously, if there's materials development, process development, new manufacturing equipment, right, all of those things are going to, I don't want to say add time, but, obviously they do, but it's more about, getting all the things in place to do something that, we or anyone else has never done before. So, yeah, it really does depend. But, again, sometimes if it's something that we think we can solve with standard material in some different dimensions, we can have parts out the door in a matter of, weeks or a couple of months. So it all depends.
Wow, very interesting stuff. Thank you for that. Sounds like it does depend on the project, but either way, you guys will provide the correct time frame depending. So that's great. All right, we're going back to the questions. And to the audience, we are in the Q&A session. You can submit your question now by entering it in the Q&A box and clicking submit. Okay, next question from the audience. When a customer comes to you with a problem, how do you fund the collaboration cycle? For example, supply material, test pieces, testing, etc.
Yeah, again, there's not really one answer for that. Depending on the project, depending on the, the customer relationship, Some things we will, we'll go back to our lab and, use some existing resources, make up some samples. Other times we'll quote the customer for, a specific test or, prototype materials for them to test. So there's not really one answer. As any business, we would need to look at the whole picture and see, what are all the moving parts here and what makes sense, from a collaboration space. But if it's a customer that we would consider a development partner, we would negotiate that and, have that discussion very early on of how to fund the project. So I'm not sure that's the most effective answer, but that's the reality of it. It all depends.
Yeah, Matt, it might be worth throwing in the recent project we had with a global tractor manufacturer that we just provided testing for, where we came in, the tractor manufacturer was looking to improve their downtime or reduce the amount of re-greasing the traditional bronze bearing application in the front end on the tractor. And essentially what we did was worked with the manufacturer. They provided the actual shafts or pins with different coating systems, as well as competitor bushings. And we priced out to test at our facility, and we also tested competitor bearings or bushings alongside of an array of ours, greaseless and greased bearings, and provided them with all the results, across the board. But yeah, just to kind of tag along with what you're saying, we provided all this information up front, a list of pricing, time frame, schedules, what we'll provide, and everything for the customer.
That's great. Thank you both. Sounds like it's a collaborative approach as opposed to just passing all the cost off to the customer. So that's great. Very good. All right, and just a reminder to the audience, we are in the Q&A session. Please send us your questions. Okay, moving along, we have a lot of great questions in here. Okay, here's our next one. You've discussed corrosion a few times today. What solutions do you have to address corrosion in the field?
Yeah, that's a great question. Let me jump back. I had a slide in here. There we go. Hopefully that comes through. So as I mentioned, we have a broad portfolio of materials, and corrosion does come up quite frequently, particularly in applications where, we're outdoors, we're in a saltwater type environment, a lot of chemicals and, fluids that are used, aerospace, we see, things like de-icing fluid and salt and brine and stuff that they put on the runways. So, we do have to address corrosion in a number of applications. And, as I had mentioned with our range of materials that we offer, so the metal polymer materials and the metals and bimetals are most prone to corrosion, both from just a general chemical attack, but also galvanic couples. Metals are certainly prone to those. The fiber reinforced composites and engineered plastics don't have any metallic components in them, or at least not prevalent. So those are typically where we look when we have very harsh chemical environments or, corrosive potential. We do also provide metal polymer materials that are on bronze backings rather than steel, which, a lot of customers that have to tolerate more corrosive or chemically intense environments do prefer to use, because otherwise it is a familiar technology for them. But the fiber reinforced composites and engineered plastics are, really the best way to approach corrosion is just remove all doubt. right? Those are not going to rust. They're not going to create couples or anything like that. Some added benefits there. We also get, electrical resistivity. We can have magnetic permeability as a requirement in some applications. So, like I had mentioned, there's not really just the one thing that points us to one material group or another. It really is a wide range of decision making and inputs to select the right material. And with corrosion, the other thing I'll mention, some applications have very specific corrosion protection techniques. So, chrome plating and zinc plating and all sorts of various, coatings and platings. The GGB coatings will also often be able to substitute in for those because they're going to protect that base metal surface as well, right? They're going to make that not exposed to the external environment. So, certain coatings have different levels of protection, but that is actually one of the benefits of the coatings product line.
Excellent. Thank you for that. And we still are in the Q&A session. We have some more questions to get through, but we have received a few thank yous and a few questions on how to follow up for some more info. Just want to point out on your screen in the top right corner, we do have the contact information for both of our presenters today. So please feel free to reach out. And you can also access the GGB website for more information as well. Okay, back to the Q&A. Here's our next question from the audience. What is GGB doing to address sustainability, and what can you offer companies looking to remove hazardous materials?
Yeah, that's another good question. We deal with hazardous materials, regulations on a pretty consistent basis. One of our legacy materials called DU actually contains lead. So that is, obviously something that we can't deploy in REACH and RoHS compliant applications. That said, we also do develop materials specifically to address changes in marketplaces. So, we have things like, cadmium plating is being eliminated, and you can't use, certain chrome platings anymore, and so on and so forth. So we do, work with customers to select the right materials to either eliminate those components or to interact with, the different coatings. So if they're going from a chrome to a zinc or, something along those lines, that impacts the tribological surface, right? If you have a shaft or a pin or something that has a zinc coating on it, that's going to have a totally different, interaction with some materials than a chrome plating would. So understanding the differences, we do have a team of tribologists throughout the world who study those types of things, who anticipate those changes, who test our materials against various counter surfaces, so that we can guide our customers when those questions come up and they say, hey, we're trying to, eliminate this or reduce our dependence on this. So, yeah, it's something that, like every industry, we're constantly monitoring for changes in, market preference, but also regulatory requirements, and those aren't uniform throughout the world either. So something that, is shifting in Europe might not be shifting yet in Asia, right? So there may be things that we kind of, step into as regulations come online. And, we're constantly paying attention to those trends and regulations to be sure that we don't suddenly find ourselves without a solution. So we're, constantly testing, constantly developing materials. That's another thing I'll throw out there. I was working with a customer recently, and we proposed a material and the customer responded, well, what is that though? I don't see it on your website. And the answer was, it's not on our website. We don't offer it as a standard material. It's something that we have made in the lab. It's something that we have evaluated from a tribological perspective. It's something that we didn't have a business case to launch at the time. But we still have those data sets. They're still cataloged in our system. We can always go back and pull those solutions and reactivate them because we have a huge breadth of materials that we've tested under various conditions. And maybe we didn't need that at the time, and now we do. We can always pull those off the shelf and start working on them and industrializing them. So long answer for yes, we are constantly paying attention to those requirements. And if you have something, we're sure we can help you out.
Thank you.
Hey, one thing I'll throw in there just to add to what Matt was saying is that sometimes we can work through hazardous materials or look at different options just by going grease-free. So keep that in mind. I know a lot of the products operate with some type of lubricant or grease. We can go back in there and evaluate with a grease-free option. So keep that in mind.
Excellent. Thank you both. And I don't think our audience minds long answers, so please keep them coming. The more information, the better. You guys are the experts, and we love hearing from you, so thank you. Quick note to Matt, please take a look at the chat on the screen. And while you're doing that, I just want to remind the audience, we are still in the Q&A session. You still have the ability to send us your question. You can do that by entering it in the Q&A box and clicking Submit. We have a couple more to get through, so we're going to try to do that before the end of the session. If we don't answer your question for whatever reason, we will have an answer for you following the webinar. Okay, now for our next question from the audience. Do you develop new materials or test existing materials for compliance with changing and new regulations?
Yeah, I mean, it's kind of a similar answer to the previous one around sustainability and some of the things that are being, legislated out of, out of various products and industries. So, yeah, I mean, we regularly develop new materials. We test them with new fluids. There was a recent example of an electrified vehicle that used a, new oil in the system. I won't go into too much detail, but basically it was attacking the bronze that is in the metal polymer material that they had been using for decades. And they came to us and said, hey, we've got a problem here. And we said, yep, okay, we see it. We know what is causing that. We recognize that it's chemical attack. Looking at the requirements of the system, we have a couple of products that can fit that bill and improve that situation. We did end up moving over to an engineered plastic, and like I said earlier, it removes all question of chemical attack and corrosion for that material. Yeah, I mean, different regulations, different shifts in the industry. Those are all things that we can test for. And in that example, we took a similar approach. We had the customer send some of their oil. We did the fluid immersion testing to prove out the concept, went back to them and said, here's our design proposal for this application, using materials we know are compatible, and after adjusting all the, clearances and expansion coefficients and everything, and designing a new part. So yeah, long story short, if you come to us with an issue, we're going to work with you to figure out if it's something that we can solve together.
Excellent, thank you for that. And it looks like we have time for one last question, and here it is. Process fluids that have both corrosives and chemicals, including amines, present simultaneously are problematic. Amines are an issue for most polymers. This is a toughie for every application that I've seen. Do you have a material that will work with these type of process fluids?
I can't speak specifically to that process fluid, not knowing more about it. Amines are a fairly broad class, although they obviously have some common elements to them. I probably would not be the best person to answer that, which is where I would pull on our materials engineering group. We have a number of polymer chemists who are very versed in chemical compatibility, on the types of materials and interactions and how to prevent them. We don't only use polymer materials though either, right? We have non-polymer materials, some of which may be more resistant than some of the polymers that we use. And it really comes down to reviewing the application in detail. So I would encourage the person who asked that question to reach out based on the contact info. I think Matt said it's in the sidebar. So feel free to reach out. I think we may be able to get back to you based on the contact info that you entered when you joined. And we can review that in more detail. Again, that's more of a polymer chemistry thing. Some of our coatings have very unique polymer properties, and some non-polymer materials that may be able to withstand exposure to those chemicals. So again, long story short, give us a call. We'll see. Let's talk it out and see what we can come up with.
Nice, very good. Thank you for that. And like Matt mentioned, right in your screen, the top right corner, you should be able to access the email addresses. You can just click on that, shoot us an email. All right. Well, that was our last question, so we are going to wrap things up right there. So guys, thank you both for that great presentation and also taking the time to answer some questions from the audience. I'd like to also thank our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. And lastly, please take a moment to complete a survey, which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.